Welcome everybody to Fine Tuning Fridays, where each week we try to dive into a new open source model and push the capabilities of what we can do with that model through fine tuning. And today we're going to be diving into this Qwen-Image-Edit update, Qwen-Image-Edit 2509, which is, I think, the date it was released. Some people are calling it Qwen-Image-Edit Plus. And if you check out Qwen's blog post on this. The update has a bunch of improvements. The main takeaway is that this model can now take multiple images as input. So if you've tried Nano Banana or you've tried some of these other image editing models, it's really cool what you can do when you can give the model more than one image as context. This model also claims to have improved consistency for things like keeping the character consistent between shots, and then other kind of like control planes that you can use. Like this one's pretty cool. You can take a reference image, another reference image, and then a third reference image. So like the person, the piece of clothing you want them to wear, and then the pose that you want them to be in, and then it combines all of that together into this shot. Um, or you could do like a hand-drawn sketch to the pose of the person that you wanted. So really powerful. This is starting to become kind of like prompt engineering for LLMs or context engineering for LLMs, but for diffusion models. And the reason that we love Qwen in general is that they are open source and Apache 2. So you can download this model off of Hugging Face, you can fine tune it, and then you can run the model weights either locally on your own hardware or through services like Oxen. You can deploy it kind of at scale with your own custom fine tunes. So that's the model we're going to be diving into today. And before we get too deep, I want to give you just like a quick rundown of how it performs, how the base model performs, and then we can dive into the task that we'll be doing and how you can actually fine tune this thing on Oxen. But to start, on Oxen, we have this nice model library, and recently you can now filter by the type of task in here. So we actually have a bunch of image editing models that you could compare to each other, like Nano Banana, or today we're going to be doing Qwen-Image-Edit Plus. Um, and if you open it up, we have this little playground here, and you can see some of the ones that I was playing with yesterday. But what's cool about this one is you can actually take multiple inputs, and we're going to be working with pose estimation itself. So I'm going to grab this image of a model, and then I'm going to grab a pose that we've put together. So I'm going to grab this one. And the idea is, can we say, take the model and put him in the pose as our prompt? You can combine these things, and it takes about like 5 to 10 seconds to generate with this service. And boom, we get the model in the pose. Pretty impressive, honestly. It kept his Nike jacket. It actually added what it thinks the legs would be, and we could even be like in camouflage. I don't even know how to spell that. Camouflage pants. Um, and hopefully it figures out, okay, his legs should go here, and instead of these black pants, we're going to give him camouflage pants. So Qwen kind of took their Qwen image edit. There we go. Boom. Camouflage pants. Pretty cool. So they kind of took their Qwen image edit and then did some additional fine tuning themselves on these specialized tasks like pose estimation. And if you scroll down in this blog post, you can see a bunch of other examples. So here's the pose one. Um, here's like putting multiple characters into a scene here. And then there's even cool ones like If you've ever done control net type things, they kind of support all of those out of the gate, like depth estimation control, and sketch as well. Uh, if you want to play around with the pose estimation stuff itself, we also added an open pose here. Um, so that's how I generated a bunch of these. So let's take like this model right here. It's funny, we're going to be saying model a lot today, and we're going to be meaning both the model in the image and the model that's generating the pose. Um, but if you want to play around with this like pose estimation stuff, you can do this all in the playground. This one takes a bit longer to boot up, but you'll see it'll kind of give you the poses here, and then once the model's hot, it's much quicker to do the second generation. So we can come back to that in a sec. But what I want to do today is walk through how we can actually improve the model performance for this pose estimation task itself. And we're going to be using the example of this Nike product catalog. Um, so let's go to NikeSportswear.com. And if you go, we're going to pretend we're working for Nike and we've had all of these model photo shoots. And maybe we want to take this outfit and have him turn around or put him in this pose. But we only did like these couple poses for the photo shoot. And now we want to extrapolate that to new poses and not have to bring him back into the studio. So there we go. That one finished. You can download these images and just kind of play with them. And this is actually how I created the data set that we're going to be using today. So the first question is, this model was already fine-tuned to be able to do this task. Um, why would we need to fine-tune it further? And especially if you're like a company like Nike, the details in these images are going to be really important for you. So let me kind of pull up an example of what I mean there. So let's take this generation as an example. Here I have the reference image and I have the pose that we want to put him in. And it does a pretty good job. But if you compare that to the actual photo shoot itself, you start to notice things like the jacket and the sweatshirt definitely look a bit AI generated. His face is like way smoother than it should be, given the reference image. And then this one on the right is like the real image from the website. So we're going to try to close this gap between this AI looking kind of like more plasticky feel to a high quality image here of the model in the scene, and hopefully preserve things like even the embroidery on the logo and the outfit itself. So that's kind of like the gap that we're going to try to close today. And just to give you like another reference of, oh, but can't Nano Banana do this? This is what happened when I gave Nano Banana the same prompt, and it, or not the same prompt, but a similar one, definitely didn't put him in the exact pose we wanted here. So Nano Banana doesn't seem to have been trained on at least this pose estimation task. I would say the realistic part of the person does look pretty legit though for Nano Banana. Cool. And then the last thing that I think will be interesting before we dive into the actual fine tuning is so all of these examples on the Qwen post, and let me find the pose one, have all of the prompts in Chinese. So Qwen is cool because it is multilingual. But one little hack that I did here that I think you guys might find interesting is I took a little screenshot of this and then put it into Google Translate images just to see what kind of prompts they expect. And if you put this guy in here. Then we do English. Um, it actually translates the image. And the terminology that Qwen likes to use is the girl in figure one changes to the posture, or sorry, the girl in figure two changes to the posture of figure one, and then they add the other things. So I think a lot of their training data like explicitly said figure one and figure two to reference whatever image is in there, and then changes posture is kind of like the keywords that they were using. So little hack if you're curious what these prompts actually are, just like toss it into Google image search. Okay, so I've prepared a data set already, and I'll kind of walk you through what it looks like and then how we can use it for fine tuning. So if you're not familiar with Oxen, on the surface, it looks a lot like Git and GitHub, and that's because we want you to be able to collaborate on these data sets with your team and version all of the data sets that go into the models and always know like exactly what trained your model. And so it looks a lot like files and folders, but if you're in a data set itself, kind of gives you a more magical view of the data set where you can render the images within it and look at the different prompts and kind of page around and make sure that your data looks exactly like you want it to. And so what I did to create this data set is I actually went to Nike.com and I grabbed a reference image as the first image in that carousel. Um, so this first one here. And then I downloaded all of the subsequent ones, or at least the ones where we had like a full person in the scene. Um, and then I, where's that data set? Here. Uh, and then I paired up every one of the first images with the subsequent ones in that sequence. So you can see this is like model zero, model zero, image one, model zero, image two, model zero, image three. And that's kind of how I organized at least these two columns of this is going to be the reference image we start with, and then this is going to be the target image that we want to aim for. And then I took our pose estimation model, and for every image in the target column, I just generated the pose of the person in the target. So our inputs to the model are going to be the starting model like this, and then the output, or the starting model like this, and the pose, and then the output is going to be this target column. So if you see this, it's kind of got like the guy turned around to the back. Hopefully the model can learn like orange means, what is that? Your like right arm, and I don't know what color the left arm is. The left arm looks like it's green. So even things like turning the person around, hopefully it can kind of learn the color codes that we have in our pose estimation model. And you might even have a different pose estimation model than the one Qwen trained their images on. So having the ability to fine tune this gives you a little more control. But that's what the data set looks like. I think I grabbed 15 different models and I tried to do a mix of men and women in here. And then for each one, they kind of have 4 or 5 different poses that I added in here. And then I also auto-captioned all of these images with our run inference feature here. And before we kick off this thing, I actually didn't think about this Google Translate trick until earlier today. So I'll just walk you through live how we can do that. And then we're going to kick off a fine tune with the verbiage that they have here. So the girl in figure two changes to the posture of figure one. So let's say look at the image and come up with the gender of the person, respond with a prompt that says the gender and the following. So, do the girl from figure 1, changes to the posture, changes to the posture of figure 2. Or, and I'll probably say woman and man instead of girl. Woman, man from figure 1 changes to the posture of figure 2. Any questions as
Eh,
I'm going along here?
Daniel had a question, Greg. He asks if we pass reference images to a model, for example, like the canonical front and back images, do you think we could like accurately generate uh, just more poses, like different configurations, kind of to extend our data set?
Because you're essentially like hallucinating the back of the product image. So like could we give like the canonical front and back and then use that as
Mm,
reference so that you're not making up what the back of the product looks like, basically.
yeah, that's a good call. So you could even have uh 3 input images, and then these two are like front and back, and then the third one's pose. Um, because yeah, somebody might have like some funky hair going on in the background, or yeah, the product might be different.
Yeah,
That'd be cool to
exactly. There
try.
could be like I don't know, different cut on the back or a logo or something. And you want to make sure you capture that product accuracy rather than making it up.
Yeah, yeah. And I think of like these hooded ones, for example, like does it have the crease here or not? Stuff like that. Yeah, it's a really good call. Um, okay, so samples look pretty good. I'm just gonna save this to a branch called like figure 1, 2, 3. Right. Cool. So what this is going to do is just go auto caption all of our images for us here and overwrite this column. Um, so we'll let that run for a little bit. And then the other cool thing is like, so we have this version of our data set, and we'll never really like stomp on any of these changes, even with overwriting the captions. So we can kind of like run multiple experiments in parallel. So while that's running, I'll show you how we kick off the fine tune with multiple references. So here we have a bunch of different tasks. You can fine tune LLMs, you can fine tune text to video models. We've done a couple dives on that in the past. In this case, we're going to do image editing. And then within image editing, we have a couple models. So we have this Qwen-Image-Edit Plus, Image Edit, and Flux Context Dev. Qwen-Image-Edit and Flux Context Dev only take one reference image in. So you'll see you could do like reference image to target image. But if you come into Qwen-Image-Edit Plus, we give you the ability to give multiple control image columns. So in this case, we're going to do the reference image and the pose, or like to Daniel's point, we could do reference front, reference back, and pose all as these input columns. And then for the output, we still only have one. And then for the caption, we also have one. And then the other cool thing that we can do here is during training, we can set some images that we want to use as our samples. So in this case, let's try that guy kind of like turning around. So we could say the man from figure 1 turns to the posture of figure 2. Um, and then let's just do 1 in this case, and I'll show you what it looks like with multiple. Um, And then you can come into here for some advanced settings. We try to set these to reasonable defaults, but the number of steps is how long you want to train it. Sample every is given the number of steps. How often do you want to generate previews during the training? Tweak things like batch size, learning rate, the LoRa size, and then how big you want your samples to be. And then you can just kick off this fine tune. once you kick it off, it'll kind of go into this list here. And this is one that we've actually completed. And you can see this is kind of what the samples look like as they're going through the training. So we'll scroll down to the bottom here. You can see at the start, like it is similar to the images that we saw just playing in the playground. But if you look at things like this, like the color isn't super accurate yet for this model and this outfit. And it's got like the pretty plasticky look for his face. And as the fine tune progresses, we get better texture on this actual piece of clothing. And the model actually starts to look more and more realistic as we're going along. Um, this one was funny because I think, yeah, after like 1,400 steps, it started hallucinating the pose like onto the person. So that was interesting. It kind of course corrected as we came back. So I don't really know what happened in those couple steps, but that is something you can watch out for during the fine tuning. It even like swapped the person here, so it must have gotten into a weird local minimum at some point, and then started to bounce back. We're gonna make it really easy to like grab the checkpoints from either one of these steps if you want to. Um, but then once the fine tune is done, we save the weights back to your repository here, your model.safe tensors, so you can download that, put it into Comfy UI, do whatever you need with it. And it's always linked back to the exact version of the training data that you trained with. So if you wanted to kick off like 4 experiments with different LoRa ranks or LoRa alphas or learning rate, or even the time steps type and stuff like that, you can do that. And then once it's done, we also let you deploy it to a playground where you can play with this thing itself, either through HTTP requests or in this playground here. So we can wake this thing up, but this is one of the ones that I generated from the fine-tuned model. And let me just pull up the difference between the fine-tuned and the base model so that we can really zoom in on, did this thing learn anything?
Greg, could we make the repo public so people can follow along?
Yeah, for sure. Boom. It's just Ox Nike pose transfer. You guys want to, or Eli, if you want to put it in the chat. All right, cool. So let's take a look. This is the one that I generated in the playground here, and then this is the one that I generated with the base model in the playground. And while, at the beginning of the episode, we were like, wow, this is super impressive. If you look at the details between these two, it's actually a pretty significant jump, both in terms of like, oh, these pants aren't really the khaki color or pattern that we wanted. His face looks a bit more AI generated and plasticky than in this one. Even the Nike logo itself and embroidery looks a bit better. The sweatshirt looks a little more realistic. So that's kind of like just with one fine tune on, I think there's like 56 images in that data set. It started to get one, the quality of these Nike photo shoots. And I could imagine if you have, if you are Nike and you have that whole product catalog, you'd be able to train like a super hyper realistic version of this. I only did it on a small subset of the models here. So pretty encouraging. And I think taking some inspiration, oh, this is another funny Nano Banana fail of trying to turn him around. It just like had absolutely no idea what to do there. But yeah, gives you kind of a sense of the quality difference you can get from even a small set of fine tuning. So we wanted to keep it a little short and sweet today, and then we can open it up for questions afterwards. If you are watching on the YouTube, feel free to join these things live on Fridays because we do kind of kill the recording and just like chat afterwards. But for everyone else, we'll see you later.